Hello, students. We are in the last part of the course, and now we have to complete the remaining part of this lecture. In the previous lecture, we discussed about the storage device, which is the hard disk. We started our lecture understanding about how do the hard disk works. That is, we have seen the internal structure of the hard disk and how basically it is created and how do we read and write the data. So the point we need to highlight here is, so we need to read the data from different part of the hard disk. Some data may be available in this in the platter, some data may be on the top surface, some data may be on the back side, some data on different tracks and different surfaces, different sectors. So to read the data faster, we need to arrange the data, or we need to put the data, or we need to put the scheduling in such a way that we can easily, or we can say quickly, we can read or write the data from the hard disk. So in connection to this, we have discussed about various scheduling algorithms, that is disk scheduling algorithms. We talked about all the concepts in this lecture, that how can we address a particular sector. First we need to go to the drive number, specify the cylinder, surface number, top surface or bottom surface, and then sector number. So then we can reach to the proper block of the data or sector of the data. And we discussed about the disk scheduling. We started our discussion understanding about the first come first serve scheduling. Here we are going to read the data according to the first come first serve basis, and after that we moved on to our remaining scheduling algorithm, shortest seek time first. Then we talked about the scan algorithm. Then we talked about the C-scan algorithm, and finally we talked about the C-look algorithm. Okay, and when we had the discussion, we talked about the advantages, disadvantages, and what are the methods of calculation of these algorithms. Please watch the lecture again to understand the concept of these scheduling algorithms. Now to move on to today's concept, we are going to discuss about the same, related to the hard disk only. We are going to discuss little bit of more details in connection to the operating system. Okay, the first point what we generally know about the hard disk is disk formatting. So whenever I ask this question in the class to the students, generally when asked what is formatting, I get a common reply. That is, the students say, teacher, it is erasing or deleting everything from the hard disk. So that is not actually it is meant by the term formatting. So first of all, we need to understand what is formatting. So when we actually create the formatting falls under two categories. One, we call it as low level formatting, and the second one is operating system level or the logical formatting. So the low level formatting, which we are seeing here, is normally done at the factory level. I mean, when we buy the hard disk, they are actually formatted. So what happens in this formatting? The tracks, the sectors, and everything is like a proper data structure is created in the hard disk. Like we have seen the picture today in the beginning, that when we create the hard disk, there will be tracks, there will be, the platter contains the tracks, and the sectors are divided, and we have the initial structure of the data. Means in the hard disk, a proper disk block is now created with a structure. So what will be there in that structure? So that structure actually contains the header area, which indicates the sector number, or I say the block number, and what is the actual data we are storing on this sector of the hard disk. So that is the data area. Usually that is 512 bytes of data we can store in each sector. Okay, and if there is any problem happens to this particular sector, how to handle that and how to correct that? So there will be error correction code, so which is mentioned here. So this is the actual structure created. I mean, we'll have the disk with all the platters, and we will have the sectors in the hard disk, and on each sector, that is actually the disk block. So what will be here in this structure? There will be three parts. So what is the header information, the actual data what we are storing onto that, and the trailer information, which is actually the error correction code. So this is formatting. So who is doing this formatting? This is done at the factory level, that we call it as a low level formatting. And when we have the disk, for example, in the computer, I'll just show you my screen. If I go to this my system, I can give right click and you will see option format. So this is also going to do a formatting, but this is not a factory level formatting. This is not a low level formatting. Already the tracks and sectors and everything has been created on my hard disk. But with the help of this formatting option, we are going to do actually a logical formatting. Okay. So what basically it's perform, you can see even on the right D drive, when I click on formatting, it's actually going to erase my data. It's not a factory level formatting, but it is going to erase my data and it makes the blocks again empty and make the hard disk ready for me to store the information with the appropriate file system according to the operating system. So this formatting which we are seeing here is called as a logical formatting. So what is that? Making an empty file system. Remember, in the lecture of file system, we talked about each operating system has got its own file system. Like Unix, we talked about inode is a file system. In Windows, we have seen NTFS, file allocation table, FAT. So different type of file systems which we studied in the file concept lecture. Okay, so that is logical formatting, and this is low level formatting. Just remember the difference. It is done at the operating system level, I'm sorry, the factory level, and this we can do in our system, which is a logical formatting. Okay, operating system with the help of operating system. Okay, another point we are familiar about is the partitioning. So what is partitioning? I have shown you the example. My hard disk is divided into two parts, partition. It is not physically breaking the hard disk, but logically one hard disk can be divided into different partitions. That's how we have C drive, D drive, E drive, F drive, different parts of the hard disk. Does not mean that we have so many hard disk in our computer. So one hard disk can be divided into parts, that we call it as partitioning. Okay, so we need some tools to do the partitioning. If you are doing at the installation level, when you are installing the operating system, we can perform partitioning, but there are some tools. With the help of that, now also when your computer is already installed with the operating system, now also we can do the partitioning. Now I can divide my C drive into two parts or three parts. I can divide the D drive into three parts. So partitioning can be done. That's done by the operating system. Okay, so sometimes what happens, some of the disk blocks, what we have talked about, they become bad. So what do you mean by bad? Like, some kind of problem may happen to them where we cannot read or we cannot write the data onto those disk blocks. Okay, so they are bad blocks. So the sectors, I'm using the word block, but I told you that sector is the smallest part we can address, so we call it as a block. Okay, so sector on the disk, sometimes they become defective. The reason can be because of magnetic fields, or the reason can be maybe a dust on the magnetic strips, or maybe any other mechanical problem, or any other virus. There are many reasons for that. So they become defective. So like they are telling like we need a strategy for preventing blocks being used. So if there is any bad block in the hard disk, okay, we need a plan, we need a strategy, so that the operating system should not go and read those blocks because they are already damaged. Okay, so like we keep extra car. Okay, so sorry, we need to keep the record of each bad block. So how do we maintain the bad blocks in the hard disk? So there are two strategies. One, we call it as a simple strategy. In the simple strategy, we run the program period, maybe once in a week or maybe once in a month, or sometimes we can set automatically by the operating system to check this, to search for the bad blocks in the disk. There is a program called check disk. The check disk is the utility which will check the health of your hard disk. So we can run this, it will tell how is my hard disk doing. Okay, so we can run some tools or utilities. With the help of that, periodically we can check and we can find the bad blocks. That is one strategy, simple strategy. Sophisticated or more advanced strategies, keep a list of bad blocks which are there in your computer, and whenever we find a bad block, we are going to update the list. So by any means, we are going to maintain the list of the bad blocks. Okay, like sometimes in the car, if you get a puncture when we are driving, so we need to have an extra tire, right? Spare tire. In the same way, if any disc block gets damaged or become problematic, we need spare sectors. Okay, so what do we mean by that? So if you take the hard disk setup, so for example, this is my disk block or sector. It gets damaged. Okay, which means I am not able to use this. So I need, for example, a spare block somewhere, so that whatever the data or whatever the way or maybe possible, I am going to shift onto this, and then I am going to use this as a spare or a extra block. Okay, and remember, these are like, in the car we have four tires, but the fifth one we are not going to use it, right? It will be kept somewhere under the car or inside the boot or some cars at the back side. Okay, so on the door. So in the same way, operating system should not see this. So that is the point mentioned. Operating system cannot see because they are all actually special blocks or the spare sectors. Whenever we need them, the operating system should use it. It should not mix up with the general scheduling of the disk reading or the writing. We should not consider these blocks. We should not use them. Normally, we know that we have the fifth tire of the car. We don't use it. We use only four tires. We need four tires. The fifth one is just the extra thing. Okay, so that is what we need to keep in mind. We need to set aside some spare sectors. What is the use of that? When we find any bad block, okay, we are going to shift the data or try to recover from that damage by using the spare sector. Same way, like when we get the car puncture, we use the spare tire if needed. Okay, so that is the concept of bad blocks. How do we handle the bad blocks? Now we are moving to another concept called RAID. Okay, so redundant array of independent disk, or we call it as inexpensive disk also. So sometimes we see this as inexpensive disk, or sometimes we see as independent disk. So what is the idea of RAID? Maybe in the networking courses or other courses, you might have heard about what is RAID. Okay, so what basically is this is sometimes we may have some problem in our hard disk. Okay, there is always a danger that we may lose our data. Okay, normally on the servers, especially in the data centers or in the high sophisticated servers, there is a possibility that we may get some problem in the hard disk and we are going to lose the data. Okay, but we don't want to lose the data. We need to keep it somewhere. Okay, we need to keep it somewhere as a backup, or at least we need to have a mechanism so that our data is protected, our data is safe. Okay, so that is this mechanism of RAID, so which we call it as redundant array of independent disk or inexpensive disk. So how do we actually maintain this? Okay, there are different strategies we are going to discuss about. So the first concept what we need to understand here is, look at the reading. So each block of the data is broken into subblocks, with one subblock stored on each disk. Means we are not storing all the data together in one location. We are breaking down the data into a block of data into subblocks, small blocks, and each small block, or we call it as a subblock, stored on the disk. When we do this, okay, so for example, we have hard disk 1 and hard disk 2. The data the data will be kept, and they need to work in synchronized, because the data is not in one location. Now we need to synchronize the rotations of the hard disk so that parallelly we can read the data from all the disks together from the at the same time. That is, the disk have their rotations synchronized, all of them work with the same speed and the same in a synchronized way. Okay, so that is basically the idea of RAID. And how do we actually apply the RAID? There are different mechanisms. One, we call it as a disk mirroring. So what is disk mirroring? I told you the mechanism here is for the backup of the data. So one mechanism here is mirroring. We know the mirror, yeah, it's the same image we see in the mirror. So what actually the disk mirroring here is same data we are keeping into multiple disk. Block 1 is equal to block 2, the disk 1 is equal to disk 2 means whatever the data we are keeping on disk 1, the same data will be on disk 2. So what is the advantage of this? Is if one disk becomes damaged, the data is recovered from another disk because we have the data backup. So which means same data like we see our mirage, our image in the mirror, we have disk mirroring. But there is another strategy which we call it as block interleaved parity. And this is the important concept you need to know. What is block interleaved parity? So block interleaved parity here, the point what I told you in the previous slide, the group of subblocks is written in a special parity block. Look at this. Okay, so this is block A divided into block A1, A2, and different blocks. And additional information is kept in another block. We call it as a parity block. I will read it again for you. A parity bit for the group of subblocks is written to a special parity block. So for every disk block, there is a parity block here. If one of the subblocks is lost, okay, so it can be recovered from other subblocks. Okay, suppose I lost the data from here, I may get the data from this disk block, or maybe I can get the data from the parity block as well. So how do we recover that? We can see one example to understand this. So block interleaved parity, first of all, what we do, a parity bit for group of subblocks is written to a special parity block, means the information about these blocks is stored in the parity block. Okay, how it is created, let's see. Okay, now have a look on this. This is disk 1, this is disk 2. Okay, how the parity block is created with the help of XR. I hope every one of you remember the XR truth table. We know the truth table from computer organization, the R table and the AND table, the gates what you have studied. So the XR, I put one slide here to make you, remember the concept. So the truth table. So when both of the conditions are the things becomes both of them the same, are both of them true or false, so we get the false value here. Okay, so if any one of them is true, we get the true value. So which means if both of them are true, we get false here. If both of them false also, so we'll get the true. So we'll just use the bits here. Okay, so 0 0 becomes 0, any one of them 0 1 or 1 0, that becomes 1, or both of them 1, that becomes 0. So we use the XR concept to create the parity block. So just check this. So 1 0, so that becomes 1 here. So 0 1, that becomes 1 here. 0 1, that becomes 1 1 here. 1 0, that becomes 1 here. So later on we have 1 and 1, that becomes 0. 1 and 1, that becomes 0. 0 and 0, that becomes 0. So which means we have created the parity block by using XR of disk 1 to disk 2. So disk 1 XR disk 2, we are going to get the parity block. Now, let's suppose we lost some of the disk. Okay, suppose disk 2 has been damaged, means my disk 2 is not working. So how do I recover the data? So we have our parity block, which will help us to retrieve or to recover the data. Okay, so how do we get the data now? Okay, so understand this. So disk 2, how do we created the how do we recover our disk 2? We have to say parity block XR disk 1, which means what we are going to do now is we are going to do the disk 1 XR parity block. So when we do this, we are going to recover our disk 2. So let's see that now. So our parity block is this one, 11110000. So that is our parity block. So the original disk 1, 100111100. So that is our disk 1. Now when we do XR on this, so 1 and 1, that becomes 0. 1 and 0, that becomes 1. So 1 and 0, that becomes 1. 1 and 1, that becomes 0. So you understand the concept, right? Now when we do parity block XR disk 1, we get this information. And now this information should be our disk 2. See the disk 2. So 0 1 1 0 1 1 0 0. So 0 1 1 0 1 1 0 0. So if any of the disk gets damaged, let's suppose if disk 1 gets damaged, so parity block XR disk 2, when we do it, we should get our disk 1 back. So this is the concept. With the help of this parity block, which we are writing as extra information here, will help us to recover the data from the damaged disk. I will read it again. A parity bit, so that's what we did it here, the parity bits. Okay. So a parity bit for the group of subblocks is written to a special parity block. That is a parity block. If one of the subblocks is lost, it can be recovered from other subblocks plus the parity block. So that is how we use disk 2 is damaged. So we get the data disk 1 XR parity block. So with the help of this, we can recover the data from different disk drives. Okay, this is the concept of RAID. So what is basically RAID? The data is maintained in more than one hard disk for the backup or for the protection of the data. Okay, so we use two concepts here. One is the disk mirroring, the second one is the block interleaved parity. So normally we use this in the server rooms for protection of the data, or in the data centers where we keep the important data so that we should not lose the data. Okay. Now we are moving to another concept. There are two more concepts we are going to see now to finish. The booting. We started our course in the beginning that the operating system, you know, booting concept. Okay, now again we came back to the end. Okay, so when we want to run the computer, it needs a program for booting. So the instructions what we see in the beginning of the computer. Okay, operating system is a secondary thing. First, when we switch on the computer, at least we need to have the small program to start our computer, start our machine to run. Okay, that's what is called as a bootstrap program. So what is the bootstrap program? The computer needs this small program to run when it is turned on. So when we switch on the computer, we see some instruction. Still our operating system is not loaded. Our operating system is the secondary thing. But in the initial thing is, suppose I buy a new computer, I need to install the operating system in my new hard disk and the new computer. But to run the computer, at least I need to make the computer to run first. Okay, so for doing that, we need to have a bootstrap program. Okay, so what it does, this small program, the bootstrap program, this program initializes the CPU register, means it activates the CPU registers so that the CPU can store the data into that, and the CPU needs the memory normally to execute. So it loads it initializes the main memory. Okay, and after that, our main operating system will be loaded and it will start execution of the operating system. So to load the kernel, I told you kernel, we discussed about that in our initial lectures, and we need to start that particular kernel program. So the initial program which we are talking about, the bootstrap program, should be in the computer. It should be in the computer, and we know our RAM, our main memory RAM is volatile, right? Means when we switch off the computer, it is going to delete everything from the computer. So for that reason, this bootstrap program is normally kept in the read-only memory. So now you should know the purpose of the read-only memory. Why do we have in the computer? It is already programmed to run this small bootstrap program, with the help of which the computer starts to run first. Okay, after that, what will happen? That is the initial bootstrap program. We are now calling it as the primary bootstrap program, that is in the read only memory. So what it does, it will start the computer, it will initialize everything, the registers and the main memory, and then it will go to the hard disk and try to find out whether there is any operating system in this computer. Okay, so where it will go and find about the operating system? If you look at the hard disk, you remember in the lecture of the file system, we talked about how the data is organized in the hard disk. Okay, So normally we have the directory. In the directory, we have the structure which says where the disk blocks for a particular file have been stored. Okay, but now we are not talking about the files. We are now talking about the operating system. So where this operating system will be kept? The operating system will be in the boot block of the hard disk. Means in the hard disk, we allocate a special space so that the secondary boot program can be kept into our hard disk in a special location. We call it as a boot block. Okay, so it loads the secondary boot block program, and then the operating system will be loaded into the main memory. Means we can see the windows in front of our eyes. So what happens when we switch on the computer? It checks. We know in introduction to IT also, in other courses also, you might have studied about booting. So what is booting? When we switch on the computer, it checks the input and output devices, it checks the memory, it checks everything. If everything seems to be fine, it will start to operate or start to run the computer. Okay, so that initial program, we are calling it as a bootstrap program, the primary bootstrap program that will be loaded from the read-only memory. And then once this program is ready in the computer, it will go to the hard disk and go to the boot block and try to load the secondary bootloader or the operating system into the main memory. From there, we can start our computer to use. That's what the behind story. Okay. So the initial program, which we talked about, the primary bootstrap program, is very small. Okay. What is that? Often it just loads the bigger bootstrap program, which is normally our operating system. Okay. And this program, the operating system, is actually going to do the remaining executions of the system. The program will be stored. Which program we are talking about? The secondary program or the big program. Okay, which means they are talking about the operating system. The operating system will be stored at a fixed location on the disk, and we call this location as a boot block. Means in the hard disk, like we have seen the picture here, in the hard disk, one special place will be allocated or reserved to store the operating system so that it cannot mess up with our data. Our data will be kept in the files. We have the directory structure. We have the information about the file allocation table, and actually we have the blocks of the data which is given for the file. So it is not mixed up or messed up with the other content of the hard disk. It is actually kept separated, which is on the boot block. Means it's a special place in the hard disk, so that directly it can go to the boot block and read the data from that place, identify the operating system, and send the operating system into main memory to start executed by the CPU. Okay, that's what happens in the background of the booting. That is called as a boot block. That is one point. And the last point we are going to discuss in this lecture is swap space management. Okay. So what is this point? Remember the lecture we discussed in the remember the points we discussed in our lecture number 7 and lecture number 8, which talks about the memory. Memory. Okay. So when we have the program or the data, remember the virtual memory and demand paging, all the concepts what we discussed about. We talked about one concept there, if you remember, about swapping. So do you remember about swapping? So what is basically a swapping? So the data from RAM need to be swapped in or swapped out to the disk or the hard disk. Okay, suppose we want to run more programs. Okay, now I have one program. I want to remove this data from here. I want to send the data into hard disk, and whenever I want to bring the data, I need to bring the data from the hard disk. Remember, we talk about this concept and we call this as swapping. Okay, now what is the point we are discussing in this lecture about the swapping is when we are sending the data from the RAM to the hard disk, where do we need to keep this and how do we need to keep this? Because this is a data going from the read-only memory to the hard disk. Is it a file? We know it is not a file. It is some data related to the program or the data the user is typing or the user is working with. Okay, so we can consider this data. I'm telling you the solutions now. How to send this data into the hard disk And how to treat this data? Do we have to treat this data special, or do we have to consider this data as a normal file? We have discussed about this point in the file system concept lecture, that we keep the data in the hard disk as files. Now this data also, I can call it as, for example, I can call it as file A, for example, and then I can keep the data about file A in my hard disk. That is one concept. Okay. So what is the question here? We are talking about how do we actually manage the swap space. Okay. Virtual memory. We talked about the lecture in lecture number 8. Virtual, sorry, virtual memory uses the disk space as an extension of main memory. So I told you, when the RAM becomes full, now hard disk becomes the extension of the RAM. It has to take the data, put onto the hard disk. Whenever the program needs the data back again, we need to bring the data back onto the hard disk. Okay. Now how do we have to implement this? How do we have to send the data? How do we have to bring the data from the hard disk? How do we have to consider this data? That is the question we are discussing here. Okay. That is swap space implementation. Now they are suggesting us two solutions for that. What is the first solution? We consider this data as a file system. Okay, swap space is simply a large file within the file system. So what they are telling, consider this data as a file, like a normal file we are keeping on the hard disk. Put the data onto the hard disk as a file. When we do that, normally we are using this swapping as an extension of the RAM. Means quickly it has to go to the hard disk, bring the data from the hard disk whenever the CPU is asking for the data. Means this operation is not like a normal file operation. This operation should be very fast. Okay, and they say the navigating takes more time. Means taking the data, converting that to the file, storing the data onto the hard disk again whenever we need, organizing the data, identifying the data, seeking the data, collecting the data, and bringing back to the RAM. It's going to take time. Okay, that's what is the first solution. How do we handle the swap space? First solution, swap space is simply a large file within the file system. Okay, when we do that, there is a problem with the navigation. It takes more time. What is the other solution? Okay, this is the solution which we are going to favor. So what is the solution here? In the hard disk, like we have the special boot block. To store the booting program, we are reserving some space in the hard disk. So in the same way, what we do now is in the hard disk, you reserve some space for swapping of the data. Means this is not a file. Whenever we want to save the data from RAM to the hard disk, don't mix up with your file system. Okay, don't mix up with your file system. Keep the data and the swap space, sorry, keep the data on the swap space, and whenever we want to get the data, you need not to search the whole hard disk. Your data is available in this special, this we call it as a special raw partition. Means this is a special partition maintained only for storing the data to swap in and swap out of the hard disk. So that is called as a special raw partition. So swap space is blocks in the raw partition. So what is the first solution? We can keep the data as a file system within the disk. Second solution, swap space is blocks in the raw partition. Now when we do this, we need not to search, we need not to find where is the data, we need not to organize like a file. We can quickly jump in here, read the data from this special location of the hard disk. So what it does, speed of access is better than file system. Here we say navigation takes more time, but here we say it is little bit faster. Okay, so there is an operating system called OS can keep swap in both file space and raw swap partition. Means they are going to use both the methods for storing the swapping space. Okay, so with this we have completed the lecture. We also completed the course. So hope you understand the concepts which we have studied today related to the complete secondary storage issues. So in the beginning of the lecture, we discussed about what is hard disk, the mechanics of the hard disk, how can we address the individual part of the hard disk, and later we discussed about some scheduling algorithms, that how can we read and write the data effectively, in quickly, from the hard disk by using first come first serve, shortest seek time first, scan algorithm, C-scan algorithm, and C-look algorithm. We discussed about the advantages, disadvantages of that. And finally, today we talked about what is the concept of formatting, what is the concept of bad blocks, what is the concept of booting the hard disk, and finally, we talked about how do we manage the swap space. Okay, so hope you understand all the concepts properly. With this, we complete our course and the lecture. Thank you.